We look at refractions of light first. Actually, what is refract? What is the meaning of refract? What's the meaning of refract? Anyone can tell? Yes, thank you, Bethany. Bending. Bending 就是折刀的意思。Bend. Bend. Okay, refraction of light is the okay, so actually bending, go straight and then bend, actually means the direction of propagation change. So bending also have the meaning change of direction of propagation. Okay, so means when the wave travels, then suddenly it changed direction, bending. So refraction means bend. Okay, refraction of light is the change of direction. Wow, I typed very hard to write. Is the change of direction of the light ray at the certain angle when it travels from one medium to another medium that is different density, right? That is different density. So you can see when the light ray comes from air, goes through the glass and come up with the air, come up in the air. Okay, the light ray that enter a medium, the light ray starts to enter some medium called incident ray. And then the angle, this I, we call them as incident angle. Incident angle. Incident angle. And this is my Mimi. Say hi. Say hi to Coco Jinjin. Hi. Hi. Okay. Okay, then when the light goes into another medium, this is angle of refraction, or angle of or refracted angle. Okay, so this light bend to certain angle, and then when it come up again from another side of the glass, we call them as emergent ray. Okay, emergent ray. Okay, can remember the name already? Okay, so now let's look at the fate simulation.为什么？怎么它可以待这么久？为什么？ Okay, so now the light travel from air to water. If it is parallel to the normal. Okay, first of all, we must know that yeah. Yes. Hello. Okay, so this is air and this is water. This is water. Okay, so the line in between medium air and medium water called boundary. Boundary. Okay. And then when the light strike on the boundary, we must draw a normal. So this line we call them as Mr. Normal. Mr. Normal. Okay. Yeah. Okay, then see if we shine the lights, let's see one. Okay, if both medium is the same, then when we shine the light at when we shine the light at I equals to 30 degrees, okay, the refraction also 30 degrees. Okay, so the refraction will be 30 degrees too. Okay, refraction will be 30 degrees too. So if there's no difference of medium. But however, if I mix this medium as glass, what do you think? The R will become less than 30 or more than 30. A or B? Like, please answer. Thank you. I done. 1 vote. BSE, thank you. 1 vote. 3, 4, 5. Hannah, Manfei. Mini. Okay, yay, everyone agree. Less than 30 because it will bend towards the normal. You can see it's 20. So you can see R become 20 means less than 30. Okay, means that's all. 我也要，我也要，咪咪过来，咪咪，咪咪，咪咪，抽奖。Okay, so why is it? Because glass is denser. Glass is denser than the air, so it will bend, means it will refract towards the normal. All right. So now, how about if I change this is glass and this is water? What will happen when this is glass and another side is water? So if I equals to 30, this is glass, this is water, R will be less than 30 or R will be more than 30. A and A or B. Yeah, I done Manfei correct. B. Yeah, B. Okay. So because this is denser, this is less dense. Okay, so now this one you all fill up, okay? Page 185, homework to later. So this one you all also fill up. So why it will bend towards normal or away from normal? So it will become more than because the velocity change. Okay, so if we use the wave, where is the wave? Okay, so we can see the wave. This is the wave we have learned in chapter 5. So you can see this is the in speed. So we can see in the beginning is 1c. 1c means the speed light, speed of light. Then enter in the air also the same speed, but when it enters to the glass, the speed decreases. That's why it will bend towards the normal. Okay. So you can see the wave outside is like this, and the wave inside is smaller. Wavelength means it's slower. Okay, so now continue. Okay, now look at page 186. So, how much will it bend? So today your homework is 185, 186, 185, 186. Okay, so how much will it bend? Depends on refractive index. Still remember what is refraction? Bending. But we don't use the word bending, we use the word diffraction. Okay, so how much will it bend? We look at refractive index. Index means a number to refer. Okay, bending, a numbers to refer. So the formula is sine I sine I, wow, sine I over sine R. Sine I over sine R. Okay, if you forget how, it's okay, formula is given. Thẳng ra cái nhập của phần 你很过分啊你诶从这里从这里过分。Okay, so you can see here got four formula. Okay, n equals to sine number two, n equals to sine I over sine R. Or we see n equals to c over v. N equals to 1 over sine c, this one later. And n equals to real h over apparent h. Okay. And then here we got one more. Number 6. N1 sine theta 1 equals to N2 sine theta 2. Okay, what's the difference among them? Okay, so we got four formula. Okay, sine I over sine R, very easy. Sine incident angle divided by sine refracted angle. And then here, we also can say n equals to c over v. What is c? C means speed of light. Okay, c means speed of light divided by speed, both are speed of light. Okay, speed of light up here is speed of light in vacuum. Down here is speed of light in the medium. No, C is speed of light. C is speed of light in vacuum. You copy first. What is the speed of light in vacuum? The formula also given. But is in page 2. Is in page 2 at the last. It's like in nuclear physics form 5 chapter. C equals to 3 times 10 powers of 8 meter per second. So we always use 3 times 10 powers of 8 divided by the speed of light in the medium. I encourage you to write the 3 formula here. N equals to sine I over sine R. Okay, then N equals to C over V. And then N equals to capital H divided by small h. Okay, so this experiment, I think we have no time to do lah. So actually is we use a glass. Actually it's same thing as here. This is air, this is glass. So we set everything. So let's say this is glass. So we start lah. we start from 10 degrees. When I is 10 degrees, when I is 10 degrees, okay, R will be R will be 8 degrees. Okay, so normally we record it on the side. We record like this. I in degrees Celsius and R in degrees Celsius. So if this is 10, this is 8. Okay, then if this is 20, I is 20, R is about 12, I is 30, it's about 20, I is 40, R will be 25. So we get 5 manipulated variables. So one more, we get 50. Okay, then this is around 20. But this is 30. And this is 50. This is 30. Hi, Chihan. Chihan, you're on camera. Okay, then we fill up the table here. 8, 12, 20, 8, 12, 20, 25, 30. Then we change I to sin I. So sin I means, oh, just now I used start from 10. Okay. So you can fill up lah as your experiment. Normally we put the unit on top, so we don't put unit at the bottom. Okay. Then we change I to sin I, means we sin 10, answer is answer is 0.1736. Okay. 174 can at least 3 decimal. Can. And side R is sine 8. So answer is 0.139192. Okay. Then we will get sine I over sine R. So it's 0.1736 divided by answer. Answer is 1.247, around that. Then we will draw, okay, once we calculate everything, we draw the graph. If the graph is R against I, so the graph is curved. But in physics, we don't want the graph become curved. We want it straight so that we can determine the relationship. So how to make it become straight? We use sine R against sine I. Then we will get a conclusion. Sine I, we will get a conclusion. Sine I is what proportional to sine R. Directly or inversely proportional to sine R. Directly or inversely? Okay, it's directly. Very good. Start from 0 means directly proportional. Means when side I increases, side R also increases. Okay, so then the gradient here could be the refractive index lah. And then if you calculate all, you will find out side I over side R almost the same, 1.2 or 1.3 something. Okay, almost the same. Okay, this experiment we will not do, no time to do. I hope we got time. Last year Form 4 having the exam on January, but yours starts November. So last year we got a lot of time to do experiment. Okay, so now this one, the next one is real depth over. So the refractive index here is the real depth divided by apparent depth. But I believe you already noticed. Okay, you already noticed they use H here. They use H here. They use H here. Real H over apparent H. Okay, so what's the meaning of depth? Okay, so D stands for depth. Okay, then the H stands for height. Okay, actually, what is the difference between them? Here they should use depth. That means from the surface, go down. From the surface of water, go down. We count from top to the bottom. Then what is height? Height is from the bottom, go up to the surface. This is height. Okay, what is real depth and what is apparent depth? I want to show you some picture first. Swimming pool, real depth, apparent depth. Okay, never mind. We can see the surface here. Actually, the tiles under the swimming pool should be always equal distance, right? But why here looks like it's smaller? So it's because of refraction of light. So because of refraction of light, if you look at a coin under a beaker, you will find out this beaker actually is more shallower than the real one. So the shallower image, we call them as apparent depth. Apparent 就是暂时性的，给我们看到的是在这里。It's something not real, but we see it appears here, so we call it as apparent depth. The real depth is from the surface to the bottom of the coin. Okay? So now can understand, we always count from top to the bottom, not bottom to the top. Alright, but formula given is height, but actually it's depth. 可以吗？深度 depth is 深度 depth is 深度 height is 高度深度 means 从上面看下去，高度从下面看上面。Okay, right, let's solve the problem. So actually, no time for you to do this experiment too. Okay. Okay, so now let's look at our tugasan 1. Number 1. The diagram shows a ray of light traveling from air to the glass. So this is air and this is glass. What page? Page 113, 131, 191, page 191. Okay, so a ray of light traveling from air to glass. Find the angle of incidence, angle of refraction, then calculate the refractive index of the glass. May I know what is angle of incidence? Anyone can tell me what is the angle of incidence? Okay, thank you, Aiden. Thank you, Bethany. Any others? Any others? 1, 2, 3, 4. Okay, congratulations. Yay! This one not for 50, but Jun Leong very good is 40. Why? Because still remember that the line in between air and glass called boundary. Yeah, from normal, Sheng Yu. So the point when the incident light ray hit on it, let's draw a normal. Yes, it's Mr. Normal. Let's draw a normal line. Let's draw a normal line. So the angle supposed to be count from normal to the light ray. Okay, normal to the light ray. So here is 30. So R equals to 30 degrees. Why sorry? I done why sorry? No need sorry. No need sorry, no need sorry. It's okay. It's okay. Many people will be cheated. It's okay, it's okay. We try. This is called trial and error. Trial and error. It's okay. So now, how to calculate refractive index since we got I and R? Which formula is more suitable? 1, 2, 3, 4, 6? Yeah, 2. So we use formula n equals, so involve first, alright? Always write involve first. Sine I over sine R. Then we substitute. Yeah, thank you, Brittany. So it's sine 40 divided by sine 30. So n equals to 1.2856. No unit because it's a number to refer. How much will it refract? Bigger the number, refract the more. How many decimal places for this chapter? At least 3 lah, but I like to use 4. 1.2286 can 1.286. But I prefer 4. Just me. When I do MS, I like to have 4 decimal. Yeah, I also. That's a good example. Okay, so now next. The light travels from air to glass. Determine the angle of theta if the refractive index of the glass is 1.42. Okay, so what is the info? Theta equals to question mark. Okay, so n equals to 1.42. Refractive index is n. So, looks like got I. What do you think what is I? 30. I is 30. I is 35. Can you speak it now? I is 43. Yeah, I is 43. Ishan is on my side. She's shy. Okay, so this is normal. Yeah, very good. So this is 43. And how to find theta? So actually, this is I. So we need to find R first. How to find R? Refractive index. Can you tell me which formula is related first? For two angle, what formula is related to two angle? Wait, show me. Yeah, only number 2 got two angle. The rest, one angle. So let's write the formula first. Refractive index means how much it will bend. So n equals to sine I over sine R. Okay, so refractive index n is 1.42. Okay, ma. So now let's substitute. 1.42 equals to sine 43 divided by sine R. our bill is so but I use you. Yeah. Okay, so sine r, this is not theta, but sine r. Theta is later. So now we will get sine r equals to sine 43 divided by 1.42. So r equals to shift sine, all of these things, sine 43 divided by 1.42. Vậy anh mà. You solve the bracket first. Sine 43 divided by 1.42. Okay, then you shift sign answer. Shift sign answer. Shift sign answer. So 28.7037. 28.7037 degrees. So actually, shift sign means you will get back the degrees. You will get back the degrees. All right. Shift sign will get back how many degrees? Okay. So now, if you have no idea, always start with info formula. Then see, this is reverse operation. Normally we get n, but now they already n is given, so with the balik find back. So this is our answer, right? Not yet. Yeah. Yes. Not yet. So what is our answer? Our answer is theta. Theta equals to 90 degrees because this is normal, minus 28.7037, 61.262963 degrees. Okay. So I encourage you all, if you have highlighter, you highlight or you just circle out, and or you always refer back. What did they want? So in exam, can we highlight it? And no problem. Just highlight on the question side, no problem. Alright, so now the speed of light in diamond is this. The speed of light in vacuum is this. Calculate the refractive index of the diamond. So actually this is V. This is C. C means speed of light in vacuum. Okay, so calculate refractive index of the diamond. May I know what is the symbol for refractive index? Yeah, very good. Thank you, Bethany. Thank you, Shen. Yeah, so see, we got B, we got C, so use formula. If you're not sure, check back. Or I encourage you to check back. Sometimes we might misplace C and V, C over V. So let's write formula. N equals to C over V. C 3.0 times 10 to the 8 divided by 1.2 times 10 to the 8. So answer is 2.5. Yeah. So 2.5 is larger than a glass. See, glass only 1.286 means it will bend the light a little bit. But 2.5, it will bend the light a lot. So let's see. If this is there, okay, now we make it as 30 again. So if this is glass, I is 30, R is around 19. Okay, sorry, yeah, 19. Okay, now let's see if I change it to diamond. Diamond. Yeah, this is diamond. So see, if this is diamond, I is 30, R is around 11. So you can see this one just bend around 10 degrees Celsius plus because refractive index is 1.28 around that level. A diamond has the refractive index 2.5. That's why you can see it bends almost 20 degrees. So bigger refractive index refract more towards the normal, all right? Higher refractive index also means denser. Higher refractive index means denser medium. Means it will refract more. Okay, so now is there any material with very, very high refractive index? Yes, diamond. High refractive index also means it's transparent. It must be transparent. 有没有东西是有很高的 refractive index 的 diamond 呢？它折它越多的，所以 diamond 算很高了咯。diamond 折很高，diamond 折很高。So high refractive index means transparent material. Yeah. So for example, if this is titanium, but we know titanium is opaque. What is opaque? Opaque means light cannot pass through. So what will happen? Only reflection. 不透明嘛，它不透明，它就只有反射，so only reflection. Reflection 则是 only for the material which is transparent. Welcome, Brittany. Okay, so now next, number 4. Diagram shows the light ray passing through the liquid X. So the refractive index of the liquid X is 1.15. So let's write it. N equals to 1.15. If the speed of the light in vacuum is this, so C equals to 3 times 10 powers of 8. Find what is the speed of the light in the liquid. So this one, obviously, we will use formula number 1. So always check back. M equals to C over V. n equals to c over v. So 3 times 10 powers of 8 divided by v. Okay, how to do it? Yeah, very good. So n is 1.15. Substitute, and we just exchange them, and we will get the number. Two 608,69565.2 meter per second. Okay. If you want to make it as shorter refractive index, I prefer you all get 3 decimal. So 2.609 times 10 powers of 8 meter per second. If you want to make it as standard form, at least 3 decimals, right? Thank you, Bethany. Very good. I hope in school we also can type. All right, so now what is the refractive angle of refraction? So here R. Use which formula? Since we got I is not mentioned in the question, but is drawn on the diagram. So we can use n equals to sine I over sine R. Yeah, number 2. Thank you, Shinyu. So n is given 1.5. Sine I is sine 55. Because we always count from normal to the light ray, divided by sine R. So R equals to sine R equals to还是直接翻完？你先换这两个先。sin 53除1.15。对呀，没有错 ，OK。对啊，这个就是 R，这是 R。你 Shift 翻过去了，它就只剩 R。Okay, so R equals to shift sine 53 divided by 1.15. So R 的几度？ Oh, sorry, 55. My pen got some problem. Cannot write properly. 45.4229，45.4229。Need to round off based on the number behind. Oops.是角。Okay, so now a coin is placed at the bottom of beaker, like this. At the bottom of the beaker, let's draw. The coin is pointed at the bottom of the beaker. Fill with water to a depth of 6 cm. Fill with water to the depth. Depth means from the surface. So 6 cm. Means this is real depth of apparent depth. So this is real depth. Real depth is capital letter. Thank you, Bethany. Yeah, it's real depth. The real one. So how much water you fill? It's the real depth lah. What is the apparent depth? So what is small d of the coin when viewed from the above one? So if your eyes view like that, what will be the apparent depth? So apparent depth is small d. Okay, if refractive index of water is 1.2. 5 cm, thank you. So we can use this formula. Number 4. Okay, this one they use height, but actually it's depth. So N equals to real depth over apparent depth. 1.2 equals to 6 divided by D. So D equals to 5. Means we count. So here to here will be 5 cm. cm, yeah. Since real depth is cm, then I have cm. So apparent depth is cm. Well, we lost mark if we write H instead of D. No need. No, it won't. You won't. Okay, how do we count the marks? Normally formula no marks. Because it's given here. So if you write D, you write H, doesn't matter. No marks. Not wrong, but no marks. Then why I keep asking you all must write formula first? With formula, you are easy to substitute. If not, sometimes some people might misplace. Like this. So I prefer you write formula because it's easier for you to substitute. Reduce the chance of having a mistake lah. So actually, the marks come from here. You substitute in a proper place, 1 mark. Then you get the correct final answer, 2 marks. Okay, so those who don't want to write formula, don't let me laugh on you. Okay, so I prefer you all write formula. Now, this one. The same thing, just we change the, see, glass block is transparent. We change the water to the glass block. So an object is placed under a glass block. The eyes of an observer is at a distance of 15 cm above the glass block. So if the refractive index of the glass is 1.25, so of the glass is 1.25. What is the distance between the eye and the image formed in the glass block? Okay, since they say glass block, means your eyes in the air. Alright, so here, so actually we are counting the real depth and apparent depth within 3 cm, like just now. Just now we are just counting the water. Okay, but the question, so we need to count the apparent depth first, then plus 50. Get it? So we say n equals to real depth over apparent depth. It's 1.25. Real depth actually is 3 because we count the glass block only. Apparent depth not sure, so we count as 2.4 cm. So 因为 glass block 只有3 cm 罢了。我们 count 的是 glass block 里面的，不用看这个距离，不用看这个距离，你看刚才这里，这是 real depth 咯，因为 object 放在3 cm 下面嘛，这 real depth 那3 cm。apparent depth 就是它从这边看下去2.4 cm，所以这个是 image 咯。image 就是在 apparent depth 那边咯。所以他现在问什么 ？What is the distance between the eye and the image form? So the distance between the eye and image form will be 15 plus 2.4. Okay, that always count from top to the bottom. So it's 17.4 cm. So we count real depth, apparent depth, we count in one medium only. Okay, we consider air does not count, no need count. Going back. No. 还要 distance between the eye and the image form. 也就是15加 2.4. Okay, so now a coin is placed at the bottom of a glass block of height 4 cm. So this is real depth lah. And then the distance between the image of coin and the real coin. Image of coin and real coin is 0.5 cm. So can you please translate? Actually, what is apparent depth? So 3.5. Yeah, thank you, Shenyu. We always count from top to the bottom, all right? Yeah, thank you, Bethany. So real depth, apparent depth, what is the refractive index? N equals to real depth divided by apparent depth. Okay, so it will be 4 divided by 3.5. So answer is 1.1429. 3 decimals okay no. Okay, the last. A stone appears closer to the surface of a pond. Okay, so 怎么可能？4, 6. Okay, so now, so when you look at, for example, when you look at swimming pool, you will always feel the swimming pool is shallower than the real ones. Okay, It's like this. Draw the light ray from the stone to the eye. So, for example, if you saw something, it's the light from this object to your eye. So we can draw the light comes from here, and then this is water, this is air. Here is water, here is air. Then on the boundary, what should we draw? The boundary of what? Boundary of what? Yeah, draw normal. Yeah, thank you, back to me. And then we know that from water to air, it will refract away from normal. Refract away from normal. Then, but our eyes thought that the light goes straight. So we thought, so we will see our image here. Our brains thought that the eye goes straight. So we see the stone is closer to us. It's not that deep. So you be careful when you go to the swimming pool, you better go to the shallower area first, then you go to the deep part. Okay, then now what is the apparent depth of the stone? Okay, so the depth of water in the pond is 1.8. So this is real depth. How much water? How deep is the water? Means the real depth. So refractive index equals to real depth over apparent depth. So it be 1.35, 1.8 divided by D. So apparent depth equals to 1.3333 cm, correct? Yeah, it's meter, not cm, right? So careful. So if you have diagram, you can always write your info in the diagram. Easier for you to check. Okay, easier for you to check. If you don't have, I encourage you to draw it yourself. Someone say, can our class finish now? No. Okay, so now 6.2, total internal reflection. Okay, what is total internal reflection? So first of all, reflection is 反射. What is 反射? 反射 means when the light comes here, it bounces back, bounce back. Total means all. Internal means inside the medium. Inside the medium. Apa itu? I found something. Let me find it out. Check it out. Okay, so mm, so okay, this is called optical fiber. You can see whatever color here will transfer up to here, will transfer to the tip. Okay, no matter how I bend it, no matter how I bend it, the light still travels to the tip, no matter how I bend it. Okay, so why this happened? Because this is called total internal reflection. Can you see optical fiber actually is transparent? Okay, supposingly the light come up, transfer out. Okay, but the light keep traveling inside the optical fiber to the end. Okay, that's called total internal reflection. Okay, why is this happen? Now this boy is using water. They're using water. Let it spill out. Okay, can you see? See me? Thank you, Mimi. That's 给它在这里吧，给它注明。Okay, so you can see the light. This is water. Outside here is air. Supposingly, it will go out, reflect out. But why it reflect in? So you can see the light keep reflect and reflect inside the water. Okay, so this is called total internal reflection. Why is it? So you can see the light keep reflecting inside. Thanks to this point. Okay, then why diamond shines? Yeah. Okay, can you see the diamond shining? Hmm? Many surface. No. This is TFR. See here? This is boundary. This is air. This is glass or optical fiber. So you can see the light goes here, bounce back. It's supposed goes out, but doesn't goes out. It bounce back and bounce and bounce and bounce. So we call this as all of the light, means total, all of the light inside the optical fiber. So we say internal reflect, keep reflecting, reflection. Not refract, it's reflect. Okay, so for example, fiber optic. Actually, our Wi-Fi cable is not copper wire, but it's using fiber optic cable. So actually, it's like this. It's transparent one, but of course, it's tinier, thinner than this. Okay. 你们要过来吗？Okay. Now see, this is our optical fiber. Last time we used copper wire, but we find out optical fiber is easier and faster. Okay, see, the light shines and reflects. And optical fiber actually got two layers. One layer is inner core, one layer is outer cladding. Okay, so how is it happen? Let's look at the fake simulation. Okay, total internal reflection happen because of you can see this. Can you see that? Can you see the light? The light suppose you can see the light suppose refract out, but at certain angle it reflect back. It suppose goes out, but now go back. Why? It's like this. First is it comes from denser medium to less dense medium. Denser medium to less dense medium. Denser medium to less dense medium. Yeah, not I bigger than R, C bigger than R. Okay, so let's check. Now this is 0. Let's check I and refracted angle. This is refracted angle. Okay, when I is 10, what happened? When I is 10, refracted angle will be, because here is air less dense, it will be more. So it's around 15. Okay, then what happened if 20? 20. So the refracted angle would be 30. Then when it's 30, the refractive index, refracted angle would be 48. Can you see the refraction become more and more? So when it's 40, it's already around 74. 40 around 74. Then when it is 42, can you see when it's 42? 42, the refraction is around 89 already. Okay, so maybe in 42.5, the refraction already 90 degrees. Okay, so now we can say that at this angle, 42.5, the light will be refracted at 90 degrees. So this incident angle, we call it as critical angle. Critical angle. Okay, means what? Means after 42.5. See, if I make it as 45, can you see any more refraction? Refract means this is refraction. This is refraction. Okay, refraction is just up to 42.3.5. Here, actually refraction is just up to 42.5. 42 or 42.5. So when your incident angle become 45, now still R, but now R become reflected angle. So R become refracted angle. 都是 cream 啊，臭家伙！臭家伙！ Okay, so now let's see 45. 45. See 45. No more refraction, but only reflection. So when this is 45, reflected angle also 45. Now reflect back. 因为它越开越大。你看啊，10的时候它折射15 when 10 refracted 15 when 20 refracted 30 when 30 refracted 48 when 40 refracted 74 40 refracted 75 lah, around that. It refracts more and more. So when it's over one angle, okay, when it is 42.5, when it is 42.5, it already refracted to 90 degrees already. can see, starts from here, refracted to 90 degrees already. 因为这是猫巢啊。哦，还有猫巢。Okay, so maximum already. 90 degrees maximum already. Then after that, if you increase the incident ray some more, it just reflects back. So we call this phenomenon as total internal reflection. So see, this is glass. The light does not go up, but reflect back. Okay, never mind. So now, today, your mission is remember what is total internal reflection. There are two. Now see, total internal reflection is a complete reflection of the light ray at the boundary between two medium when the light ray is in the medium with higher refractive index. Higher refractive index. Okay, so okay, so the two condition here is a must to memorize. The two conditions that must be fulfilled for total internal reflection. Number one is light ray must travel from an optical denser medium to optical less dense medium. See, the light is come from glass, denser medium to less dense medium, and incident angle of I must be bigger than critical angle C. So in this case, what is the critical angle? What is the critical angle? Actually, it's 42.5 critical angle. So before this, only got refraction. And after 45, 50, 60, 70, 80, all got refraction. Here, if I increase 50, 60, 70, 80, all reflect back. All reflect back. Okay. So there are two conditions for total internal reflection. Number one, the light travel from denser medium to less dense medium. Second, incident angle I must be bigger than C, critical angle. Okay. C is a critical angle. Okay, then what is a critical angle? So look back to our diagram. Critical angle is an incident angle which refract the light in 90 degrees. So I make it back to 42. 42. I can see that it comes to the 90. Okay, so what is C? C actually is an incident angle. This is past year 2020. 2017. They ask what is critical angle. Critical angle is an incident angle which I type which refract light in 90 degrees. 90 degrees. Critical angle is incident angle where refract the light in 90 degrees. So when I refract to 90, normal place it can refract, so only can 反射回去。它不能够再折射了，因为它折到不能折了，所以现在还是反射回去。Is there only one critical angle? Yes. Every material only got one critical angle. Okay, so for example, glass is around 40. So this is diamond. Sorry, this is diamond. So diamond has smaller critical angle. It's around 20 something. So diamond, why the diamond can shines like diamond? Because actually the diamond reflect the light inside and out. Okay, so the answer for total internal reflection is in the last time I sent you the module. We can continue next week lah. Okay, we can continue next week in the class. So please bring the module to the school. Okay, so now after this will be the lens and mirror. I already have class on May. You can go to check back. I scared no time to finish, so we just left one more calculation. Okay, so today your homework is please do up to 196. Just now is 180, right? To 196. Just fill in the blank. Calculation we can do in the school. So calculation we can do in the school. Just fill in the blank. Right? Fill in the blank. So actually, rainbow also got total internal reflection. Mirage also got total internal reflection. And some others like periscope also got total internal reflection. And this is optical fiber, our Wi-Fi fiber. Okay, so up to here only. Any other question? Okay, if no more, then we can rest. Thank you, everyone. Where to where? 180 to 196. 不是啊，这样是哪一个176是吗？From refraction to the TIR, or total internal reflection. Normally I call it as TIR. Okay, so that's all. Thank you, everyone. Bye bye. 客气，等你。耶，大家很开心。耶，拜拜。